Hello, this is Team K.E.E. presenting on Robert Metcalfe and His Law by Edward Carrizales, Karen Gallardo, and Anit Trevino for the Monday admin class. Who is Robert Metcalfe? He was an engineer, technology executive, and venture capitalist who invented the Internet. He was born on April 7, 1946, in Brooklyn, New York, but grew up in Long Island, New York, to the son of an engineering technician. As an electrical engineering student at the Massachusetts Institute of Technology, Metcalfe showed little inclination to sleep. He paid for college by working nights as a computer programmer from midnight to 8 a.m. Then he hit the tennis courts for several hours a day as captain of the tennis team. After graduating from MIT in 1967, he enrolled as a graduate student in applied mathematics. However, this solid middle-class student found bad attitude at the school grading, and he spent his free hours working in a computer lab at MIT. There, he was assigned the task of building an interface allowing early internet servers to talk to each other. As I stated before, he attended MIT and Harvard University studying mathematics and computer science. After completing his PhD in computer science at Harvard University, he was hired to join CERN's Palo Alto Research Center. There, he was charged with tying together a prototype of new personal computer called the Alto, which used graphic interface and mouse. After graduating, he went on a technology journey which started in 1979 when he left Xerox PARC to launch 3Com, a firm devoted to selling commercial versions of Ethernet and other networking products. When the company went public in 1984, he became a multimillionaire. At 3Com, he continued the relentless pace he kept since college, frequently working all night on new projects and assembling a group of fellow all-nighters engineers who became known as Metcalfe's Midnight Pizza Team. Metcalfe left 3Com in 1990 after he was passed over by the board of directors to become CEO. He spent a year as a visiting fellow at the University of Cambridge, and in 1992 joined InfoWorld as publisher, CEO, and weekly columnist. In 2007, he was inducted into the National Inventors Hall of Fame. So you might ask yourself, what is this law that I'm talking about? Well, Metcalfe's law states that the value of a telecommunications network is proportional to the square of the number of users of the system, also as n squared. This was first formulated by Robert Metcalfe in regard to the Ethernet. Metcalfe's law explains many of the network effects of communication technologies and networks such as the Internet and World Wide Web. Therefore, the more people connected to the network, the more powerful the network becomes. Here I'm going to give some advantages and examples about the law. The law has often been illustrating using the example of fax machines. One single fax machine is useless, but the value of every fax machine increases with the total number of fax machines in the whole network, because the total number of people with whom each user may send and receive documents increases. This diagram in the middle with telephones shows the number of possible connections grows rapidly as more users adopt a network. Others have suggested that the formula significantly underestimates the value of adding new users to a network and have refined Metcalfe's law. Nevertheless, it is the principle that it is important that online networks and communities derive more value the more users they have. The principle also helps to give an economic reason why there can be a benefit in one technology vendor or standard dominating a marketplace, because otherwise the potential users can be split across multiple incompatible platforms. Social networking in peer-to-peer systems such as eBay, YouTube, and MSN derive considerable benefit from being more or less the de facto standard for their particular online service. Another example is a phone network. A single phone really just being an endpoint in a network called a node. Obviously, today there are billions of nodes within a global cellular network. So by punching in a simple phone number convention, we can use our phone to access the network, which we pay for, and connect to another node anywhere in the world. The value of the network to you as a user rises exponentially over time with the number of phones added to the network. Next, we will go about the distance. The disadvantage about the law is that as the network grows in value, they become exponentially more at risk to cyber attacks. The law states that the value of any network is proportional to the number of users. From a practical standpoint, usability is proportional to functionality. That is, the use of a network is proportional to its functionality. The more it can do, the more people will use it. From a cybersecurity standpoint, each additional function or application running on a network increases the threat surface. It becomes vulnerable as attacks can happen at both the application service through an API and in the connections between applications through malicious packets. As you can see, some of the threats include internally employees and contractors, externally hostile nations, terrorist organizations, and criminals. Some of these attack types include malicious code, incremental payloads, brute force, impersonation, and conspiracy. But I believe that the advantages outweigh the disadvantages within this law. To sum it all up, Metcalfe's law is often cited as an explanation for the rapid growth of the internet, or perhaps more especially for the World Wide Web on the internet. Together with Moore's law about the rate at which computer power is accelerating, Metcalfe's law can be used to explain the rising wave of information technology that we are riding into the 21st century. Once again, this is Group K.E.E. on Metcalfe's law. Thank you so much for your time.